Hey guys, welcome back to class. And yesterday, what did we learn? We learned about three types of static route configuration. One using next hop, another using exit interface information, third using both. Correct? And then we saw how to change the AD value of static route. Next, we learned about dynamic routing protocols. Why do we call it dynamic routing protocols? We learned that, and then we saw the overview of RIP and EHRP. So today we will learn about OSPF. Okay. So guys, in EHRP, yesterday we learned that we use autonomous number to group the EHRP routers. Correct? We use autonomous numbers in EHRP. Why do we use autonomous numbers? To group the routers configured with EHRP protocols. I showed you this example. Assume this is the multicast IP address, and all the routers which are configured with EHRP are belonging to this this multicast group. Correct? Then again, using autonomous system, we can group the routers. Correct? Similarly, in OSPF also we have grouping concepts. Okay, in real time we will have so many routers in the network configured with OSPF. Okay, so we group it using area concept. Okay, each team will have one area. For example, take sales, IT and HR team. Okay, each team will belong to one area. So if we consider management team, okay, management team will have, assume, 3 routers. These 3 routers will be connected to one switch. Okay, we have to group it. So we will use something known as area concept. We will group these routers using area. All these routers belong to one area, which is area 0. Next, assume another team. Why do we group the routers? What is the answer you can give for this? Why do we group the routers? Why do we need grouping in the router? Okay, for that we can use one multicast IP address, no? But again, why do we group under OSPF? See, all OSPF routers are in one group, one multicast group. But in that multicast group also, we will group them using area concept. Why? Take a wild guess. Okay, that is one answer. That can be one answer, but they can belong to same domain also. And still you can group them. Why? Simple, so that we can manage the routers. In real time, there will be so many routers, correct? In the network, how do you just OSPF configuration? Is it enough to manage thousands and 10,000s of routers? No, not possible, correct? Assume there was 5 branches. Each branch has one OSPF configuration. Is that good enough to manage 5 branches? We need something known as grouping concept. The whole group, the whole NH, all the 5 branches will have OSPF configuration. They will belong to one multicast group. But again, in that multicast group, we use area concept. Each networker's branch will belong to one area. Now, in this, if all these routers belongs to one area, what will happen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Network admin has to maintain 11 routers, which is under one area. If we group it, it will become much simpler. We have made 3 groups and one group managed by one network admin. Isn't that simple? Easier to troubleshoot? Understood? Why we use grouping, area concept. So we will group it. Area 2. This is which team? Management team. You can keep this as sales team. You can keep this as HR team. Okay. So in our CCNA syllabus, we will learn intra-area communication. During explanation, we will learn about inter-area communication. But in CCNA syllabus, we have only intra-area communication. How do we configure the routers when they belong to one area? That's all. When we go to CCNP, we will make 2 different areas, and try to do communication between the areas. Okay, so by default, area 0 is called as backbone area. Okay, communication within the area is known as intra-area communication. Communication between two areas is known as inter-area communication. Okay, let's come to PPT. Okay, so these are the basics. Then we'll go to the area concept. So OSPF stands for Open Shortest Path First. Okay, OSPF is a link state protocol, which means it takes decision based on bandwidth. It always chooses higher bandwidth route. Okay, works on protocol number 89. What is AD value of OSPF? 110. Okay, OSPF has two multicast IP address. They have two multicast IP address. 224.0.0.5. This is used by all the routers. 224.0.0.6. This is used by DR and BDR. What is DR and BDR? We will discuss. Okay. It works on Dijkstra's algorithm. Okay. OSPF uses area concept. Area concept uses numbers. How do you identify the areas? Area 0, area 1, area 2, area 3. We need to identify the areas. So area is a 16-bit number and it can also be a 32-bit number. You will learn this in CCNP. OSPF uses DR and BDR. This we will see what is DR and BDR. Next, OSPF is a classless and supports VLSM CIDR. It supports classless subnetting. So OSPF also uses something known as process ID. This we will see when we are configuring the routers. Okay, what is process ID? DR and BDR in the next few slides we will see what it is. Did you guys understand why do we use grouping concept, area concept? Okay, OSPF we use in real time. Okay, in our lab experiments we are using max 10 routers. Okay, max will be 10 routers. It is easy for us to configure, but in real time there will be thousands of routers. It is very tough to manage thousands of routers under one area. So we have again divided those routers into different areas. How do we divide it? We can assign, for each team we can assign one area. Guys, did you understand area concept? We need areas to group the OSPF routers, and area is a 16-bit or 32-bit number. Okay, we have to recognize areas, correct? To recognize areas, what do we use? We use numbers like 1, 2, 3, 4. And by default, in OSPF, area 0 is known as a backbone area. Why? We will see now after you note down these points. Yeah, multicast IP address, we have two. One, all the routers in OSPF use 224.0.0.5. And we have something known as DR and BDR. Okay, what are those? We will learn. See, DR is like a class leader. BDR is like a backup class leader. And class leader is absent, BDR will come up. We will see what it is. Okay, we'll come back here. So guys, what do you call for communication within the area? Within area 1, within area 2, within area 0. What do we call it as? Intra-area communication. By default, there will be no communication between different areas, two different areas. But if we want communication between two different areas, then all the areas should have a connection with area 0. Okay, we cannot connect area 1 and area 2 directly. If we want communication between area 1 and area 2, there is only one way. We have to connect area 1 and area 2, area 0. Okay, now inter-area communication is possible. Whenever we want inter-area communication, we have to connect one of the router in this area, area 1, and one of the router in area 2 to area 0. This is why we call area 0 as backbone area. Area 0 connects all the other areas and helps to communicate between each other. We cannot connect directly area 1 and area 2. Okay. Yeah, now if area 1, if this router wants to communicate to this router, the traffic will go like this. Okay, we cannot make a connection directly from area 1 to area 2. This is not possible. And if we don't connect, what will happen? If we don't connect this router and this router to this router and this router, there will be no communication between area 1 and area 2. Okay, keep it simple. Understand this. Within the area is known as intra-area communication. Between two area, it is known as inter-area communication. And if we want communication between two areas, those areas have to be connected to area 0. Let it be area 1, 2, 3, 4, 5, anything. If we want communication between those areas, then they have to be connected to area 0. Without connecting to area 0, if this link is down and this link is down, then area 1 and area 2 cannot talk to each other. But within the area, it is possible. These routers can talk to each other within the area. But these routers cannot talk to area 0 routers and area 1 routers. Okay, understood so far? So why do we call area 0 as backbone area? What definition can you give after this explanation? Why do we call area 0 as backbone area? Tell it to me in your own words. Okay. Area 0 helps the other areas to communicate to each other. That is why we call it as backbone area. How to make connections or configurations between area 1 to area 0 and area 0 to area 2, you will learn in CCNP. Inter-area communication, you will learn in CCNP. Intra-area communication, you will learn in CCNA. Area is how many bits number? 16 bit. You can also make it 32 bit. Did you guys understand so far? By default, no communication between two different areas. If we want communication between two different areas, we have to connect those two areas to area 0, and then only communication will be possible. Simple. Understood? Shall we move to the next point? Okay, fine. If I make this link down, will area 2 and area 0 be able to communicate? If I make this link down, will area 2 and area 1 be able to communicate? No. If I make this link down, can these routers talk to each other within the area? Good. Okay, then we'll go to the next point. I'm taking 4 routers. Okay, in routing we have something known as neighbors. What are neighbors? Basically, what are neighbors? People who live next to us. Correct. Similarly, routers have neighbors. For R1, neighbors are, see, for router, directly connected routers are known as neighbors. Directly connected. Okay. Here for R1, who are the neighbors? Directly connected. R2, R3 and R4. For R2, who are the neighbors? R1, R3 and R4. For R4, R1, R2, R3. For R3, R1, R2, R4. Understood? Neighbors. Directly connected routers are known as neighbors. Okay. So with this directly connected routers, they will have something known as neighborship. Now you guys will have a good understanding with your neighbors. Correct. Similarly, routers, they will have something known as neighborship with their neighbors. R1 has R2, R3, R4 as its neighbors, directly connected routers. With these 3 routers, it will have something known as neighborship. Okay. So if R3 gets any new information, if R3 gets any new information, it will give these informations to R1, R2 and R4. Correct. Whenever you prepare some special dish, you will go and give it to your neighbors. Correct. Correct. No. Similarly, if these routers get any new information, they will provide that information to their neighbors. Why? Because they have neighborship. Understood? Okay. So in router, we have something known as split horizon rule. What does that rule state? Whenever you receive a new information from any interface, that information will not be shared back again to the same interface. Now, R3 has got new information. It has provided that information to R1, R2, and R4. R1 has received that information through this interface. R1 will not share back the same interface. Sorry, R1 will not share back the same information again through this interface, because R3 already provided it to R1, so it will not provide it back to R1 again. R3 has got some new information. That information, as soon as it gets, it will give it to R1, R2, and R4. New information. Okay. What will R1 do? In all the routers, there is something known as split horizon rule. According to split horizon rule, if the router receives any information on any interface, the same information will not be shared back through that same interface. Now R1 has received this information from this interface. Okay, so what will R1 do? R1 will share that new information to R2 and R4. Will it share to R3? No, because it received the information through this interface. It will not again share the same interface through this interface. Understood this point? Split horizon rule. Okay, next. R2 has received this information, new information. What will R2 do? R2 will share this information to R4 and R3. Because it has got this information from R1. Wait, we will form a loop. Okay. So R4 has received this information from, it has received this information from all the three. First, it has received from this. It will not share. It will receive from here. It will not share. Then last, again, it will receive from R2. So what will R4 think? The information provided from R2, that will be forwarded to R3 and R1. What do you guys see here? There is a loop, correct? These are the problems in EIGRP, RIB. See, we cannot see, but in the background, these loops will be happening. So because of these loops, what is the disadvantage? Time wastage, also CPU usage, RAM consumption, memory consumption. There is a loop. First R3 will send the information to R1, R2 and R4. What will R1 do? R1 will leave this interface and it will forward to other routers. R2 will leave this interface and forward to other routers. R4 will leave this interface and forward to other routers. Eventually, what will happen? The same information, whatever the router has sent, it is getting back, but from other routers. So loop is happening. Correct? So to prevent this loop, in OSPF, we have something known as DR and BDR. Designated router and backup designated router. Okay? First, take down these points. This point, have you guys noted down? Okay. Split horizon rule. Okay? And take down the full form for DR, BDR, and DRO. Okay, guys, wait. What is ABR? I'll tell you what is ABR. ABR is a simple thing. Okay. Now, we are connecting area 1 and area 0 and area 2. Correct? We call these routers as ABR. Area border router. This router is only providing connection between area 1 and area 0, no? ABR. Area border router. The router which is connected to area 0 and area 1. The router which is connected to area 0 and area 2. Area border router. We call these routers as area border router. routers which are providing connection between two areas. So whenever if this router wants to communicate to this router, what will happen? Tell me, how will the packets flow? This router to this router. This router will first forward the information to this router. Since this router has the connection with area 0, it will forward the information to this router. And this router will forward the information to this router. Then it has to enter area 1. How will it enter area 1? Through this router. Later, this router will forward the information to this router. We can connect, but keep it simple. We can make all of these routers as area border router, but if I do that, you will get confused. Yeah. So this, you guys understood? ABR? Okay. DR, BDR and DRO. ABR means area border router. DR means designated router. BDR means backup designated router. And then we have DRO. So in a network, we will have designated router, backup designated router. All data routers are known as DRO. So in the class, we will have one class leader, that is DR. We will have one backup class leader, that is BDR. All the other students are known as DRO. Good. You guys understood so far? Area concept. And then we saw split horizon rule. Correct? Information received from one interface. That same information will not be shared through the again same interface. Okay. Next, we saw the loop. Correct? The loop which is happening in the background. Okay. Because of the loop, there will be unnecessary CPU usage and RAM consumption. So to prevent that, we have a solution in OSPF. To overcome those drawbacks, we have a solution in OSPF. So that is DR and BDR. What is it? We will see now. Done? Okay. So to overcome this loop, which is happening in the background, we have come up with DR and BDR concept. What does it say? We'll see now. I have taken 6 routers, and all these routers are connected to one switch. And I am putting all these routers in one area, one single area, which is area 0. Okay. Router R1, router R2, router R3, R4, R5, R6. Okay. Yes, we'll go back to the previous diagram. First, we'll see what DR BDR is, and then we will see how to elect DR BDR in this diagram. Okay. So here in this topology, we know that loop is happening in the background. So to prevent the loop, we will select one router as, we will select this router as DR. We will select one more router as BDR. This is DR. This is BDR. Okay. So what will happen is, whenever there's a new information on any router, assume there's a new information on R2. Previously, what was happening? R2 will just forward it to all its neighbors. Correct? And then eventually loop will start happening. So to prevent that, we have come up with DR and BDR concept. So in this concept, what will happen is, whenever a router gets any new information, they will first forward it to DR and BDR. Both of them will get that new information. Okay. DR is like a class leader. BDR is like a backup class leader. Okay. So whenever a teacher has some announcement or a HOD has some announcement, first what he will do, he will inform it to class leader and backup class leader. Okay. DR will verify the information, and then DR will provide all that information to these routers. Okay. Even though R2 received the new network information, it will not store that information in its database. As soon as R2 gets the new information, first what it will do, it will forward that information to DR and BDR. Both of them will get the information. DR will verify the information. After verifying the information, it will communicate to all the other routers, and then these routers will store it in their database. Understood so far? See, even though R2 got the information, it will not store it in its database. First, it will forward it to DR and BDR. DR will validate the information. After validating the information, DR will give that new information to all the routers. Whatever information which comes from DR is legit information. That information will be stored in the routers. Suppose if DR goes down, BDR has all the information, correct? Because these routers are also sharing the information to BDR. Okay, if DR goes down, BDR will come up, then BDR will start acting like a DR. So BDR will start validating the new information and making the decision whether other routers have to store that information in their database or no. Simple. Now there is no loop. R2 will not send any information to R4. New information. Okay. Now if one of the student in the classroom has some new information, he wants the whole class to know. Okay. What will the student do? First, he will go inform the class leader and the backup class leader. What will the class leader do? He will cross-check with the teacher. He will validate the information, correct? And then class leader will inform all the students in the class. Okay, DR and BDR. These routers are known as DRO. This is also DRO. All the other routers other than DR and BDR are known as DROs. Good, understood DR and BDR concept. Shall we go to the next topology? So first, let's assign IP addresses to these routers. I will assign 192.168.10.10. Okay. Next, 192.168.10.20, 192.168.10.30, 192.168.10.40, 192.168.10.50. Then we have 192.168.10.60. Cool. And also I will introduce one loopback IP address in all the routers. 1.1.1.1. Okay. 2.2.2. 2.2.2.2. 3.3.3.3. So far understood. I have assigned the IP address and there is a loopback IP address in each router. Okay. And all these routers are in same area 0. So here if we do not elect DR and BDR, there will be loop in the background. Loop will be running and then CPU usage and memory usage of routers will be high. So we will elect one DR and BDR. How do we elect? We have criteria. Okay. First criteria is to elect DR and BDR. First we elect DR. First we elect the class teacher and then we will elect the backup class teacher. Okay. So what is this? First criteria is highest priority. Which router has highest priority? Okay. Priority can range between 0 to 255. By default, value of priority is 1. First, we check the priority. By default, all these routers has priority as 1. Good. Okay. First criteria is highest priority for DR. Okay. Suppose if this was 100, what would happen? R1 would have been selected as DR directly. Okay. But here in this condition, we have priority is same on all the routers. Priority is 1 by default on all the routers. If we manually make it to 100 or 50, then it will increase. So when we increase the priority during DR and BDR election, this router will be directly elected as DR. First criteria is highest priority. But in this condition, we have same priority number for all the routers. So then second, it will see highest router ID. Okay. Highest router ID. Okay. And to select the router ID, we have 3 ways. Cool. To select the router ID, we have 3 ways. First, we see highest priority. If priority is same on all the routers, then we have to check router ID. So to check the router ID, we have 3 ways. Okay. First, the router will check if there is any manual entry for router ID. We can manually enter a router ID. That you do it in CCNP. Manually, you will enter a router ID. Okay. If there is no manually, if network admin has not entered any manual ID. Second, what it will see? Highest loopback address. So here, first criteria is highest priority. Since it's all the same, it has to go for the second criteria. In the second criteria, it will look at the highest router ID. To select the highest router ID, first what it will check if we have entered any router ID manually. We have not entered. So it will look at the second step. What is the second step? Highest loopback IP address. So looking at this topology, tell me which will become the DR. Good. R6 will become the DR. This has the highest loopback IP address. Suppose if we had not assigned any if we had not assigned any loopback addresses in the routers, there were no loopback addresses in the routers. So third, what will it see? Highest physical interface IP address. Now, suppose if there was no loopback IP addresses in these routers, what would it look at? Physical interface IP addresses, the highest one. So then who would become the DR? R6. Again, R6 would become the DR. Understood so far how to elect DR? First, it will elect the DR. First, the class leader will be elected. Next, it has to elect backup designated router. Okay, backup for the class leader. How does it select? To elect the BDR, it will look at the second highest priority. Okay, now if I had made this as 100, this as 10, who would be the DR, who would be the BDR? The router which has the highest priority would become the DR. The router which has the second highest priority would become the BDR. Okay, understood? In our topology, we have same priority number for all the routers while electing BDR also. So now what is the condition? Second highest router ID. To select the second highest router ID, what will it see? First, it will check if the network admin has entered any manual entry. If network admin has configured any router ID manually. In our criteria, in our topology, we have not entered any manual configuration for RID. So second, what will it see? Second highest loopback IP address. Which router has the second highest loopback IP address? R5. So R5 will be chosen as BDR. Suppose if there were no loopback IP addresses in the router, then what would it choose? Second highest physical interface IP address. Which router has the second highest physical IP address? Again R5.
R5.
Okay, understood how DR and BDR is elected? For DR, always the highest priority or highest router ID will be checked. For BDR, we check the second highest priority and second highest router ID. To select the router ID, we have three ways: manual configuration, loopback address, third preferences, physical interface, IP address. For DR, we see the highest manual ID manually configured. We do not have any manual configuration for RID. So second, it will see highest loopback IP address, that is R6. Suppose if there were no loopback IP address, highest physical interface IP address, R6, DR. Next is BDR. Again, priority number is same for all the routers. It will look at the second criteria, second highest router ID. To select the second highest router ID, first again what will it check? Manual configuration for RID. We have not done that. So second, what it will see? Second highest loopback IP address. Which router has second highest loopback IP address? R5. So R5 will become the BDR. Suppose if there were no loopback IP addresses, it will check the second highest physical interface IP address. So R5 again has the second highest physical IP address, 10.50. So R5 will be chosen as BDR. Good. Understood DR and BDR election? Okay. Make a note of these points. What is priority range? Priority ranges from 0 to 255. By default, what is the priority number? 1. Boys, understood so far? OSPF. Okay. Online guys, any doubts till now?
No, sir.
Good. Yes, DR, BDR is only for OSPF. Interview questions. Okay, this will be the interview questions. How do you elect DR and BDR in OSPF process? Remember these points. Okay. Next, mainly what they will ask: AD value of OSPF. What are the two multicast IP addresses of OSPF? Okay. And which router uses 224.0.0.5? All the routers in the network use 224.0.0.5. 224.0.0.6 is used by DR and BDR. Good. So tell me, in this topology, if R2 gets any new information, which multicast IP address will it ping? Which multicast IP address? 224.0.0.5 or 224.0.0.6? 224.0.0.6. R2 will ping that new information to 224.0.0.6. So that time DR and BDR both will get the information. DR will validate the information and then DR will ping which IP address. It has to reach all the routers in the network 0.5. So R1 will validate the information, then R1 will ping that information to 224.0.0.5. So all the routers will get that information from DR. Any information which you get from DR is legitimate, it is valid. What will those routers do? They will store it in their database. Understood? Good. So this question they will ask: how does routers use those two multicast IP address? How does DR use it? How does BDR use it? How does DRO use it? They'll ask you what is ABR, what is ABR, what is DR, what is BDR, what is DRO. These full forms you have to know. What is DRO? Okay, good. Done? We will look at the slide, then we'll come for configurations. Okay? So, if two routers are configured with OSPF configuration, what will they do? They will exchange their database to exchange informations. R1 will inform all the information what R1 has. R2 will inform all the information what R2 has. So R1 and R2 are exchanging their database When there's functions, what do you do with neighbors? Whatever switch you have prepared, you will go give to your neighbors. Your neighbors will again give you back whatever switch they have prepared. Understood? Yes. Again, there will be a re-election for BDR. Good question. So guys, tell me, in this topology, now DR goes down. What will happen? DR goes down. So BDR becomes the DR. Who will become the BDR? R4. This will become the BDR. Okay. Now BDR goes down. DR is still up. What will happen? Re-election will happen. This will still remain as the DR. R4 will become the BDR. Okay. Understood? So two routers, they have OSPF configurations R1 and R2. What will they do? They will first exchange their database. Whatever information R1 has, it will share it with R2. Whatever information R2 has, it will share it with R1. Okay. And there are states between this. We will see that OSPF 7 neighborship states. Okay. Initially, what database is down before you configure OSPF. Once you configure OSPF, database will become up. Okay. Initially, database will be down. After you configure OSPF, database will become up. Next, what will happen? R1 or R2, either one will initiate a connection. Hello packets are sent. Hello, I want to form the neighborship with you. Either one of them will exchange or both of them will exchange. Okay. Next, once the neighborship is formed, DR and BDR election happens. Who is the class leader? Who is the backup class leader? Okay. Next, goes into exstart. Master and slave election happens. This you will learn what it is in CCNP. After that, exchange. Database starts getting exchanged. Before that only, if you exchange database, what will happen? Loop. Before DR BDR election, if you exchange database, there is possibility of loop. Here there are only two routers, so there will be no loop. But you saw the previous topology, there loop can happen. So first what it will do, it will elect DR and BDR, then exchange of database happens. After that, it goes into loading, which means if any information is missed or any packets are being dropped, it will recollect it. Missed data packets are being reloaded. Next, successfully loaded the database. Both of them exchanged their database and they have updated their database. R1 has sent all the information what R1 has. R2 has sent all the information what R2 has. Now R1 has all the information of R1 and R2. R2 has all the information of R1 and R2. They know about each other. Neighborship. Okay. Understood this? Neighborship states. Good. Next, we have OSPF packets. What are OSPF packets? Hello packet. Why hello packet? To form the neighborship. Configure OSPF configuration on both the routers. What it will do? First, it will exchange hello packets. It's like a shake hand. We both can be neighbors now. To form the neighborship, hello packets will be exchanged. Next, what will happen? Database description. Okay. Suppose if R1 has 1 GB of database, will it share 1 GB of database to R2? It will not share 1 GB of data to R2. It will just share the description of it. Suppose R1 is CCNA router. R2 is CCNP router. R1 will not share all the information of CCNA students in network or so. R1 will inform R2, I have information of all the students, all the CCNA students in network or so. It will inform that, but it will not provide the whole database to R2. R1 will just inform a description of database. I have all the information of CCNA students in network or so. It will provide the description. What will CCNP router do? CCNP router will inform R1, I have all the information of CCNP students in network or so. Okay. Database description. Okay. Next, link state request. If R1 has any query, if R2 has any query, they exchange link state request. R1 needs some information, R2 needs some information. To get the information, it will exchange link state request. Okay. R1 will share a link state request to R2. R2 will provide that information. Link state update, or R2 has got some new information in it. Okay. Will it send the whole database just to give that update, that one network's update? What will R2 do? R2 will send a link state update. An update packet will be sent. That's it. What will R1 do then after getting the update packet? It will acknowledge. Got the update, I have got the information. Okay. Understood these points? Hello packets to form the neighborship. Next, database description. It cannot send the whole database, correct? 1 GB of database can it send? No. It will make a description of the short description of the database. That short description will be sent to R2. R2 again will send its short description to R1. What will R1 or R2 do after exchanging the database? It will make a link state request. Okay, you can forward me these informations about the database. Okay. Next, then link state update. Then R2 will share its database information to R1. Good. After update, acknowledgement from R1. Okay, I have got the information from you. I have got your database information, whichever you shared. Acknowledgement. Understood this? Make note of these points, then we will see practically. Understood OSPF protocol? What is OSPF protocol? Full form, huh? Guys, in interview, don't give answers like this is easy, this is simple, this is tough, this is complex. These kind of small differences, if you give, they will not like. See, full forms are good, but after that, add more weightage points. In college, we used to do just to fill up the differences to get marks. We will write simple points. Don't do that. This is a simple network. This is a complex network. This kind of simple answers we used to give just to make 7 points, 8 points. See, even if you're mentioning 5 points, mention 5 valid points, which are really good, technical. So then they like it. Easy points, anybody can tell, no? So in interview, they might not ask you this neighborship states. Hello packets, I might ask. But learn even this neighborship states. Once you go to CCNP, you will learn about, for OSPF, you have around 12 hours of lecture. So you will learn about this in deep. 10 to 12 hours of lecture only for OSPF. For EIGRP, it is around 14 hours of lecture. For BGP, it is around 8 to 10 hours of lecture. You will learn about BGP. See, routing is a heavy module. So if you finish routing, switching will be less stressful for you guys to learn. You can go to switching and then also go to routing. That is not a problem. But if you do routing first, you will get a better clear of the picture. So now that I've removed RIP from CCNP also, you have saved 5 hours. Or else there would have been 5 to 6 hours of lecture on RIP also. but now RIP has been removed. Yeah, in CCNP syllabus also you most probably don't have RIP, but static you have. Around 1 month or 1 month, 2 weeks or 1 week it will be routing, then 1 month switching, then you have advanced CCNP advanced. When you go to CCNP advanced, you will learn more technologies about how WAN is working, how internet is working on WAN side. Here we are all learning about LAN side. WAN is much more complex. The actual internet, how it is working. You will learn about MPLS topics. You will learn VPN topics. You will learn advanced HSRP topics, redundancy protocol topics. Done? Shall we go to the practical? Okay. Boys, help me build this topology. So we can finish it off in 20 minutes. But let's go slow. You guys help me build the topology. Which switch do I take? Why do I want a switch here? Huh? Why do we need switch? Give individual answers. To connect routers. We can connect routers directly now. Okay. Hey, that we can communicate. We can connect these routers directly now. Why are we using switch here? Okay, look at the topology. Huh? 6 domains? You have 6 domains here? Okay, single domain. See, look at the topology. Give me the answer. Why do we need switch here? Port size? Okay. Any other answers? Intra-area communication. For that we have area, no? We are making this area 0. So on all the routers, we will tell you belong to area 0. That is how we make it intra-area communication. Okay, there is no subnetwork here. There is only one network. Partially correct. See guys, here we have 6 routers. All the 6 routers belongs to one domain. Okay, they are all under 192.168.10.0 network. Correct. Only the last octet is changing. First 3 octet are constant. So they are all under one broadcast domain. But in router we have only 2 interfaces. How do we connect 6 routers to each other? We cannot do that. So we want all these routers to be under one single domain. So we are connecting it to switch. Routers have only 2 interfaces. Okay. Each router we can connect it to. Okay. On router, each interface belongs to one broadcast domain. Correct. Can I connect R1 and R2 and R3? Yes. Good. Can we connect it like this? R1, R2, R3. Same broadcast domain. Can we do this? Same IP addresses, okay? Can I do this? Can I assign 192.168.10.10 here and 192.168.10.20 here? I can't do that because each interface belongs to one broadcast domain. On router, every interface has one broadcast domain. Understood? That is why we can't connect R2, R3 to R1. So what do we need here? Switch. When we take a switch, what is the feature of switch? Switch belongs to one single broadcast domain. Correct? So what do we have to do? We can connect. We can connect like this. So now all the routers are in one single broadcast domain and connected to each other. Understood why we are taking switch? I think you gave me correct answer. No, you gave me partially correct answer. You said single broadcast domain. Correct. Simple, guys. So in interview also they can give you this kind of topology and they can ask you question, scenario based question. Simple network only they will give. So in interview what will happen? You will be knowing the answer, but you will not be confident to tell that answer. Almost everybody here knew the answer, correct? But you guys thought it might be wrong. So keep revising the concepts. That time you will understand that this is the answer and you can give it confidently. Okay? Area 0. All the routers belong to single broadcast domain. Sorry, single area. Okay, now 192.168.10.10 here. 192.168.10.20. 192.168.10.30. 192.168.10.40. So you guys are good at initial configuration, assigning IP addresses. 1.1.1.1. Okay. We have to do initial configuration. Tell me guys, initial configuration. First, enable configure T. Okay. Okay. Interface. We will give host name. Host name. Let it be R1. Okay. Interface. Check the interface. F0 by 0 on all the routers. Yes. Okay. F0 by 0. This is for first router. Yes. IP address 192.168.10.10. Next 255.255.255.0. Next no shutdown. Okay. You are also configuring a loopback IP address. Loopback IP address here is interface L1. Okay. Remember this is not 11. This is L1. IP address 1.1.1.1. 255.255.255.0. IP address. Loopback IP address 1.1.1.1. Okay. Do I have to give no shutdown here? No? Good. Let's paste this configuration. Enable configure T. Hostname R1. Interface F0 by 0. IP address 10.10. No shutdown. Loopback 1.1.1. Good. Come to R1. What should I give here? No. Good. Paste it. What is the command to check? Do show IP interface brief. Okay. Assign. See. For R2. What should I change? Just tell me what should I change here. Host name R2. IP address 20. Loopback 2.2.2.2. Is this correct? We are configuring it in R2 now. This is R2 now. New router. Correct. Come to R2. Here. No. Paste it. Do show IP interface brief. We have configured. Next. R3. CLI. No. Okay. This should be 30. Hostname R3. Good. Is this correct? First loop back IP address in all the routers. Okay. Do show IP interface brief. Assigned. Good. Come to 40. No. Make it R4. Make this 40. Make this 4.4.4. (10.40) assigned, 4.4.4 assigned. Next. Router 5. CLI. No. R5. Make this 50. Yes, assigned. The last router. R6. 60. 6.6.6.6. Done. Initial configuration on all the routers finished. Okay. Next, we have to do OSPF configuration. How do we do OSPF configuration? We will look at the syntax. Simple. Just 2 lines command. Wait. What is it? Router. Which protocol? OSPF protocol. We have something known as process ID. What is process ID? On routers, there are OSPF database. Correct? Database. Each database needs one identification. How do you identify database? Using process ID. What are databases? You can consider like books. Okay. Router has made notes in its books, and each book is identified using process ID. Okay. When you configure OSPF protocol, OSPF database will be formed in the router. And to identify the OSPF database, we use process ID. Process ID is again a 16-bit number. Okay. Second statement. What do you see? Network. Next. Network IP. Wildcard mask. Any guess what is wildcard mask? Good. Opposite of subnet mask is wildcard mask. Suppose if subnet mask is 255. Wait, let me write it down. Suppose if subnet mask is 255 or 255.255.0. Wildcard mask is opposite of subnet mask. It will be 0.0.0.255. Understood this part? In OSPF, we use wildcard mask. If subnet mask is 255.255.255.0, wildcard mask will be 0.0.0.255. Simple. Okay. Come back here. What is the next thing you have to mention? Area number. Done with this? Okay. Come back here. Paste that. Come to R1. In configure mode, okay? Router, give a question mark. Do you see these protocols? We will choose OSPF. Give a question mark. What do you see? Process ID. Number can range from 1 to 65535. Okay. We will give router OSPF 10. It's our wish. We can give any number 10. So come here. Okay. Network. Then what should you give here? Network IP 192.168.10.0. Wildcard mask 0.0.0.255. Area 0. Simple. This is in R1. How many networks does R1 has? How many networks in R1? We have loopback IP address. What is the network IP of it? 1.1.1.0. What is the wildcard bits? Wildcard mask? Again 0.0.0.255. Area 0. Paste this configuration here. Next in R2. You can again name it as router OSPF 10 only. What is the networks here? 192.168.10.0, 10.10, 10.20, 10.30 is the IP address of physical interfaces in router. 2.2.2.0. These are the networks present in R2. Correct. That's why we are what are we doing in dynamic routing protocols? What do? We advertise the information what we have. So we mention all the networks we have. Correct. These are the networks in R2. It has to advertise. So we will use those network IPs in routing protocols. So R2 has advertised all the information what R2 has. Oh, R1. Oh, thank you. Sorry guys, make this 1.1.1.0. Thanks, buddy. Okay, come to R1. Paste it again. Just add a no, and that route will be removed. Okay, R2. Two dot 2.2.2.0. Now is it correct? Paste it in R2. Next R3. What are the networks in R3? 3.3.3.0. Is it in R3? Okay. Come to R4. Is it correct? Come to R4. Okay. R5. R6. What do you see here? Databases have got exchanged. Loading to full. Come here. What do you see this? Neighbor. Do show IP route. You have informations of all the loopback addresses. Correct? R2. Neighbors. Neighborship is being formed. C means connected. Local means this network is present in the R2 itself. We have 2.2.2 network in R2, so local. O means OSPF. Okay. Yes, we can change the process ID too, but to avoid the confusion, I have used same process ID in all the routers. Come to R3 to show IP route. So you have all the loopback IP addresses informations. You have, see here, 6.6.6 is local because that network is present in R6. AD value 110. Okay, now let's check. Why has 2.2.2 become the BDR? R1 has become the DR. Any guesses why? Because even before we finish the OSPF configuration in all the routers, election already happened. Come to R4, check in this. See, we were slowly configuring all R1, R2, R3, R4, R5, R6. During that process itself, it has decided DR and BDR. Election already happened. So what we will do, come here, interface F0 by 0. Shut this down. Interface F0 by 0. We are making DR and BDR down. So re-election will happen. Correct? Wait for some time. What do you see? Neighborship lost with 2.2.2, 1.1.1 network because R1 and R2 are down. First, which one was elected? 6.6.6. Why? DR. Next, what was elected? BDR. Same command. Who is the DR? Who is the BDR? Understood? Now we can make this up. Will this again become the DR and BDR? Wait for some time, neighborship will be formed. Which is the DR here?
R6.
BDR. We discussed DR and BDR. Just wait for a few seconds. The neighborship is becoming up. Come to R4. You see the state? In which state is it? Which state is it? R2 has now come to init state. What do you see now? R1, R2 has come up. DR and BDR is DR is 6.6.6. R6, BDR is R5. Understood how it is elected? Okay. Now if I make R6 down, who will be the DR? R5. And who will become the BDR? R4. Okay. Do you want to see the scenarios? Done for the class, or do you want to see it? Yeah? F0 by 0. Online guys, is it fine if we extend for 5 more minutes?
Yes, sir.
Shut it down. This is down now. This would have become the DR. And this would have become the VDR. Come to R3. Wait. Do you see? DR election has happened. BDR election has happened. In which state is this? Exchange state. Will load the full. Yes, loaded. Who has become the DR now? R5. Who has become the BDR? R4. Correct. Now, I will make this. No, wait. I will make this up. Will there be a re-election? There will be no re-election. DR and BDR will remain same. Suppose if DR goes down, then there will be a re-election. Or suppose if, okay. Now, right now, who is the DR? R5. Who is the BDR? If you want, I can cross check. Okay. R6 is DRO. Okay. R6 is DRO. Now, I will make R4 down. Tell me what is the changes. I'm shutting down R4. Who is the BDR? DR is still up. I'm making R4 down. So BDR is down. Tell me, will there be a re-election? There has to be a re-election. There is a DR, but we need a BDR. Who will become the BDR? Who will remain as the DR? Good. R5 will remain as the DR and R6 will become the BDR. What do we see? R6 has become BDR. DR will remain like that only because DR is not down. DR will remain like that only. R5 will remain as the DR. But R6 has become the BDR. Good. Okay. Online guys, any doubts? Guys, remember this point. If DR goes down, then there will be a re-election for DR. BDR will become the DR. If DR goes down, BDR will become the DR. And then there will be a re-election for BDR. Okay. If BDR goes down, then there will be a re-election for BDR only. Okay. Online guys, no doubts? Okay guys, no doubts means we are good to end the class.
Okay,
Let me
sir.
just check Adil, Prashant. Okay guys, online guys, I'll mark the attendance for you, no problem. I have marked down the names. We are good to end the class. Thank you guys.
So thank you.
Bye guys.